Szydagis, welcome to the Anomalous Review.
Great to be here.
Yeah. So you and I both just came back from Huntsville, Alabama for the Scientific Coalition VOAP Studies Annual Conference 2025. You gave a presentation on some new research that you've done that involves material analysis. Do you want to tell us what sort of materials you analyzed?
Yeah, no, I did talk about materials analysis I'm working on. So there's this famous part called the art part, or there are many parts, plural. They go back to Art Bell from Coast to Coast AM. I don't know the full history. I know Linda Moulton Howe was involved in it somehow. Maybe she got it from Art. Art allegedly got from a crash in New Mexico, late 40s. Like not quite Roswell, but close by. I don't know the whole. Because to me, look, I'm not a historian. I don't care about the history. I care about what's the physical evidence say. But it's supposedly from some UFO crash. And some people call it the magnesium part. Some people call it the zinc part. Some people call it the bismuth part. It has all three of those elements and many, many, many more. And what I did was to do my own elemental analysis, hopefully going towards also a deeper isotopic one as well. I presented some of my preliminary findings at the SCU conference last weekend. They're not peer reviewed yet. They're not finished yet. So they're preliminary, they're initial, but I'm very happy to finally have some supposed physical evidence instead of just, photos and videos. Photos and videos are great of UFOs, UAP, but it's nice to have a piece of physical evidence from an alleged crash.
Yeah, something that you can sort of reproducibly experiment on or analyze.
Exactly. Yeah. Something that I can run multiple tests on. It's not going away, right? It's not disappearing. And that's really nice. Yeah.
So you got your hands on these parts precisely because they'd been analyzed before. You're not the very first person to look at these or a piece from the same collection of parts. I think Gary Nolan has looked at some of this stuff. Is that right?
Yes. I don't know what Gary Nolan's looked at. He has all kinds of samples from different locations. So I can neither confirm or deny whether he has the same samples or similar. I just don't know.
Sure.
I do know that there is an official error report on the sample that I used or on the larger piece from which my smaller piece was taken. And that error report also involved Oak Ridge National Lab. And as I mentioned in my talk at SCU, there were a lot of elements missing in the error report that are very clearly in the sample, not, below threshold. And so it's very strange. So the error report is incredibly incomplete. And it's very strange because they supposedly use cutting edge material analysis technology from Oak Ridge National Lab that, it's super expensive and, it's classified. But if that's true, why was I at a lowly university with very few resources able to do a better and more thorough job than the U.S. government and one of its national labs? So there's something very, very wrong with this picture.
Okay, so let's back up then. This part has a history of having been tested and analyzed. There's a clear chain of custody, at least going back to the 70s or 80s or something. But
I do not know. You're asking the wrong person. So Jared Yates might know the answer to that. He's the guy I got the part from. He's the head of Flux Space on the Northwest Coast, and he I don't know if we have a solid chain of custody back to 47. And so I can't claim for certain. I don't think it's been carbon dated. So I don't know for certain the provenance or the dating. I think that's very, very sketchy, unfortunately. I think we can make a strong case that by the 1990s it was known and existed and in multiple locations being tested by people, and potentially the mid 80s. But earlier than that, I'm not sure how strong the chain of custody is from Art and Linda backwards to the 40s. I'm not sure how well that can be established.
But is it at least going back to Oak Ridge? We know that.
Oh, yes, 100%. There's no, beyond a reasonable shadow of a doubt, I have a piece of the same mother piece, larger piece, that is very clearly in the Oak Ridge report. And I know this because I'm finding the same elements in the same proportions as they claim in their report. I'm just finding more. I think their report's incomplete, but I think that it's very, very clear there's the same part that is in the Arrow report. And in the Arrow report, they do claim it's from the 1940s. But I do believe they have soft language on that, again, without knowing the provenance and chain of custody fully.
Sure. Okay. So what does the part look like first? Like, is it just a shard of metal that they've kind of shaved off of this larger thing?
And it's a piece of metal. So one side is darker than the other. Under a microscope gets very interesting, but that's not what I tested because I'm just looking what it's composed of. So in terms of like the microscopic structures and what those could be saying, that I'm the wrong person to ask. So Jared knows all about that. He's the world expert on testing this part right now, Jared Yates. And so I cannot speak competently about the microscopic structure because my goal and all the other the tools that I have are for determining what is it made out of.
Right. So we can distinguish like two general questions that are being asked into these analyses. One is just the question of composition, like what elements are in there and at what ratios. And then the secondary question, which is not what you do, but what Jared did, is what sort of structure do those elements comprise, or what structure comprises those elements? You didn't ask that question, Jared did. You asked the question of like, what is the actual material involved here? What are their ratios? And also like, what are their isotopes, right? So exactly. What is the battery of tests? Like you did tests that are different from those and more expansive than those that Oak Ridge and previous testers seem to have done just from looking at their reports. What did you do? What tests did they do? And what tests did you add to that?
The one test that I'm aware of being done conclusively, because it was actually published, it's in the Air report, is ICP-MS. And so that's a form of mass spectroscopy, and that requires destroying a sample. You have to vaporize it. It's destructive sampling, or you have to use laser ablation of a surface, but then you don't know if you're getting bulk samples. And so what I did... It's
like a high school level explanation of what that test is.
Sure. You're basically... high school level would be hard. For my high school, it would work. But I think
freshman college
high school... Okay. You have to... You destroy a sample, break it up into individual atoms, and then you use a magnetic... You shoot the individual atoms... You ionize them, shoot them through a magnetic field, and then what you do is look at the radius of curvature and where they land in your device, because different masses of ions will have different radii of curvature in a magnetic field. So that allows you to count individual atoms and figure out what their masses are.
So you shoot them through, you take it apart, you have all these atoms, you shoot them through an electromagnetic field, and then they sort of line up by what they are or what their mass is, right? And you can look and see how much is on the particular area of the line and count the ratios.
That's right, yeah.
Okay, so but that's destructive.
Very crudely, yeah.
Yeah, but that's a destructive analysis. You can only do it so many times, and once you've done it, the material that you now have information about is at least disentangled itself.
It's gone, yeah.
So you did some of that. What did that find?
I didn't do any of that.
Or Oak Ridge did that.
Oak Ridge did that. And they found magnesium, zinc, bismuth, a few other smattering of other elements, cadmium, thallium. Like, just saying these words not going to mean anything to people, though, because we also don't know with this type of testing, how do those elements come together? So a good example of that is somebody could ask, well, what's hydrogen for? Ooh, I found hydrogen. Yeah, hydrogen is a gas by itself, but inside of water, inside of H2O, it's got completely different properties. So just knowing what the elements are, that doesn't tell you anything about function, structure, nothing of that sort. They did do isotopic ratios of at least some of the elements in there. I think of the magnesium and I believe of the lead, and found consistency with terrestrial isotopic ratios. But they don't say any other than concluding it looks like terrestrial. They can't include what it is or what it's for, because the elements that are in there doesn't seem to be a reason that those particular elements are in there. And it's primarily, so most of the elements, I should stress, are very, very low level. And so it's very hard to say whether they're contaminants or purposefully added, because most of the material is like bismuth and zinc. Magnesium and zinc and some bismuth, and everything else is a very, very small trace. And so it's very hard to say, are those just accidental traces that come along with the other elements, or were they put there on purpose, as Gary Nolan has discussed in the past?
Mm-hmm. So give us a quick primer on what an isotope is and what it tells you when you find like different isotopes of a particular element.
So we have the same elements everywhere in the universe, and science fiction always gets this wrong. It's the same periodic table, same elements. There's no, magical 115 out there or whatever, like it's the same elements, same periodic table everywhere in the universe. And we know this because of spectroscopy. We can look at the lines of light from distant stars and distant galaxies, the same elements everywhere. This is how a few centuries ago, for example, we determined the sun is a star and we figured out what stars are made of. So the same elements everywhere. However, every element is made up of one or more isotopes. So what is an isotope? It's the same element. As far as chemists are concerned, it behaves exactly the same way. But as far as nuclear physicists are concerned, they can behave differently because their nuclei are different. They have different numbers of neutrons. So elements are defined by the number of protons. That defines an element. But elements can have variable number of neutrons. If they have too many, they can become radioactive. But there are also certain magic numbers, essentially, of neutrons where an element with a given number of protons is stable. And so you can have different forms of the same identical element. They look physically identical externally. They behave chemically absolutely identically, but they have very slightly different numbers of neutrons, which means they have very slightly different masses. And on different planets and in different star systems and different locations within our galaxy, you may have different ratios of the stable isotopes within elements. And so that's one of the ways to determine if something's from the moon, from Mars, from Alpha Centauri, or somewhere else, is to look at the ratios of not just one element, but across multiple. And so if you just have one element whose isotopic ratio is out of whack, that's not very conclusive because, we do isotopic enrichment. We as humans can change isotopic ratios. They can be changed in nuclear explosions, nuclear reactors, so they can be changed naturally. However, if you could detect multiple elements that they're all out of whack, have the wrong isotopic ratios compared to Earth, and all of them are consistent with each other, consistent with some specific distant location, that would be pretty close. Still not 100% conclusive because the skeptic could always BS something, but that's pretty close to smoking gun evidence that you have a piece of something that's extraterrestrial. We do this all the time with meteorites, for example. You can look at isotopic ratios in meteorites and determine, it's from, the interstellar meteorites are extremely rare. Avi Loeb has been looking for them. We mostly have ones from inside our system. And so the isotopic ratios are pretty similar to Earth, but can still be different from other bodies in our system.
So they have different isotopic ratios because of the sort of radiation conditions that they have been sitting in their whole life or were formed in, correct? Like if a chunk of iron formed much, much closer to the sun or closer to a very different star, it might have a different isotopic ratio?
I actually have no idea. I only started looking at this recently. I'm not an expert on this. All I know is that they differ by location, but I honestly don't know the mechanism. I don't think it can be the one you just said, though, because we're talking about stable isotopes here. And so I'm not sure if radiation could play a key, because radiation typically will make stable isotopes radioactive. But maybe you're right. You could be right. I'm not sure what causes different isotopic ratios in different locations.
Sure. But there's some sort of, it has to do something with the formation of the element itself, right? And the conditions.
Yeah, how it was formed in that star system. Yeah.
Right. Might have been kicked out of a different star with a different.
Yeah. Some of it, I think, has to do with like low versus high metallicity of certain stars. And when I say metallicity there, I'm talking about the way astronomers use the term. So like only hydrogen and helium are non-metals. Everything else is called a metal. If you're an astronomer, literally every other element in the periodic table is a metal. But there are different types of stars, different parts of our galaxy, and it has to do with the history of our galaxy and galaxy formation. But there are parts of our galaxy that are higher or lower, not in different types of elements, and within those elements, there are different isotopes.
So if we had a chunk of iron that fell out of the sky, and it had just wildly different isotopic ratios from the iron that we find here in the ground on Earth, we could reasonably say this is not terrestrial iron, but we probably couldn't say this is where in the universe it came from.
Well, we could. It depends. No, it depends.
You can say like Alpha Centauri, for instance.
Maybe. It depends. If you had more than one element and more than one isotope in each element, then you might be able to build a more robust case. But if you're only looking at one isotopic ratio of one element, that's probably not sufficient. So there's the famous, Ubatuba case that Robert Powell was investigating, looking at samples of magnesium. I know why it's always magnesium coming up, right, in these things, but basically they're only looking at one element, and they didn't even get consistent results on the one element. And I think that's the danger when you have only one element. You really need multiple, because otherwise, like you just said, you might be able to tentatively conclude it's not from here, but it's going to be very hard to say where it's from.
So when you were looking at this, or let's go back to Oak Ridge. Oak Ridge is looking at this, and what they do is they get ratios of some elements.
Yes, I don't know why they didn't do it for all of them. I'm going to try for more myself.
Do you think that does the report from Oak Ridge say this is the complete list of elements that we got out of our analysis, or does it just say here are the ratios of some elements that were in it? I think they're too smart for that, right? It doesn't say here's the complete list. And I know for a fact it's not a complete list because just a few months ago, Hal Puthoff posted on the TTSA website. I actually didn't know to the Stars Academy even existed still. Yeah, I hadn't heard anything from them for years. All of a sudden, they right at me, I'd messaged Hal that I was working on the art party, and all of a sudden, I saw like he had posted that, hey, everybody, here's our analysis, and it had way more elements in there, and it happens to be the ones I've been finding as well. Way more elements than in the brief Arrow/ORNL report, Oak Ridge report. So I don't know what the hell's going on, but the official published report from Arrow via Oak Ridge National Lab is woefully incomplete. Even not just in terms of what I'm finding, but even they knew better. At least the fragment that Hal has that's from the same part. It's complicated, right? I don't know. Yeah. I know very little about the provenance and who passed what part to whom, and this whole chain of custody is a huge mess. Huge mess. So I'm just focusing on was it made of? Is it anomalous? Is it not anomalous? Divorced from any chain of custody story, because even if the chain of custody was a lie or wrong compared to what we know, if it's anomalous, that doesn't change the fact it's anomalous. You know what I mean? Right. Absolutely.
It doesn't change the fact that it's anomalous if it turns out, it doesn't go back to 47, but only to the 80s. It's still anomalous. It still doesn't change it. If it is anomalous, it doesn't change that.
And so now we can get to the question of, is it anomalous, at least via your analysis? What did you find that was in addition to or even in conflict with Oak Ridge's report, and what do you make of it?
Well, I found that the material seems very much to it very much seems like to be a specific type of radiation shielding. And I'm not talking about general radiation like alpha, beta, gamma, X-ray, but it seems to specifically be a very good neutron shielding. And in particular, it seemed to, I didn't get any result by putting the sample together with, this was with Mark Sokol, friend of Jarrett's, who's from, he's from Vulcan Space, same of his aerospace company. And Mark and I, we went and we used my plutonium source I have on campus to try to activate the sample, do neutron activation, which would make the sample temporarily radioactive, and plutonium did nothing. So it appears to either reflect or absorb neutrons very well. We barely got any data. We got some data from my californium source, which has a different energy spectrum than plutonium for its neutrons. But still, the sample seems to be really, really good at either reflecting or absorbing neutrons or both, which is very interesting because it's not made of the elements that are primarily for that purpose. So, for example, gadolinium I use in my dark matter experiments. It's well known to have one of the highest neutron capture cross-section for at least one of its isotopes, and but that's not in the sample in any of the reports, including in my analysis. But there are other things that do seem to have, when they're combined in some nonlinear fashion, seem to do an equal or better job than some of the usual suspect elements in isotopes for neutron capture and absorption. So it's the one thing that I think I could definitively say, because I've seen absolutely no definitive evidence that it does any magical space-time warping, that's a magical terahertz waveguide with lasers. There's all these myths and legends and nonsense surrounding the arts parts. I've seen absolutely zero evidence for all of that. But what I do have is very strong evidence that at least one purpose of it, this part, at least the one fragment I had, appears to be that it was some sort of neutron radiation shielding. That was really the first takeaway.
The way you found this is you took this literal physical sample, you stuck it next to a piece of plutonium, and it for a while. How long did you leave it?
A month.
Okay, you left it for a month, and you would expect, if it were a normal piece of
anything, literally anything, list anything any substance you've ever come across in the world.
Then after a month, I would open up whatever box it's in or whatever, and this thing would then be radioactive.
Should have been
radiating, and you got nothing off of it.
Correct, nothing, absolutely nothing, not even a tickle. And meanwhile, my californium source was barely working. That has a more of a prosaic explanation since it's been a few half-lives, so my californium source is dying. But it's really odd that the plutonium, which is a broad spectrum neutron source, through it, and it's also got a lot of alpha N reactions. So in the particular plutonium source I'm using was PuBe, so plutonium beryllium. So plutonium makes a lot of alphas, not specifically neutrons if it's not being, hasn't been enriched for fission, et cetera. But it was also coupled to beryllium, which makes a ton of so you produce an alpha N reaction and you make a lot of neutrons, and this should have been producing a broad spectrum of neutrons that should have been, at least some of them should have been getting absorbed by the part. So the part is very small. I only had like a very tiny piece. It was only like 6.7 milligrams, and so it's milligrams, not grams. So very, very small physically in size, a few millimeters across. But that's why I left it for a month, because I did some math and I calculated that to compensate for the fact that the part is so small, to make sure I get sufficient flux of neutrons to be able to see something. It was absolutely nothing, not even a little bit. And that was a very, very surprising result. Anything else I put next to that plutonium is radioactive after a few hours, because the neutrons from the plutonium beryllium source will activate any material. It's such a high flux source. It's very, very high, very dangerous. So it's a very, very high flux source, and it's very unusual. So the one thing I can say for sure about the ARC part, at least the one I had, is that it does seem to have some kind of immunity to neutron irradiation, which is very strange. That doesn't bode well for the interstellar craft hypothesis, because neutrons are not the most important for interstellar radiation. Gamma rays, cosmic rays are much more important. And so it doesn't doesn't quite perfectly fit the hypothesis that it's some sort of ablative hull of, some extraterrestrial craft.
Mm-hmm. So do you have an order of magnitude guess for how radioactive it should have been after a month sitting next to that plutonium? And
yeah, I should have gotten at least a minimum a few thousand counts per second. I didn't get anything above background.
Literally zero?
No. There's no such thing as literally zero, because there's always background radiation all around us.
Yeah.
I just got background, which was like 3 or 4 on the device that I was using. That's the background for that particular device I had in my hand at the time. So there was nothing above background. I was expecting at a minimum, several thousand counts per second when it was removed off. And again, I can only give you a ballpark because the number varies greatly with what the composition of a material is, right? So some materials will be much lower, much higher, but none of them should be zero or, or zero above background.
So is the idea that its resistance to neutron radiation has to do with the particular isotopes that it contains, or the structural relations among them, the way that they're stuck together?
I don't know. Probably doesn't have to do with the structure, but then in that case, maybe the material has multiple properties. Maybe it has to do with the structure, some kind of channeling of neutrons is possible. That might explain some of the claims, it's a metamaterial. People throw that word around and they have no clue what that means. A metamaterial is just a very fancy way of saying a waveguide. And most of the time it's an artificial waveguide for photons. And what if it's a waveguide for neutrons? I don't know. So there's possibility it has to do with the structure, but I'm not going to know until I simulate it. So my plan is to simulate the material in just the same software we use for developing nuclear weapons, nuclear reactors. I'm going to use the same software that's used by professional nuclear physicists and engineers, of which I'm not. I'm a particle physicist, which is similar, but I'm not exactly a nuclear physicist, but I know the proper software tools to use. So I'm going to try to simulate these elements with these ratios and see if I can replicate the neutron radiation behavior. But the thing is, that's going to just be throwing them all into a hodgepodge. It will be really, really hard. I can't do this. I could try to do this. It's very, very hard to simulate the actual 3-dimensional structure and layers that has been observed through microscopy. That is extremely hard. So my goal is to just pretend that it was just a soup of all these elements. You just throw them into like a ball of all those elements in a simulation, and then throw neutrons at the material and see what happens. That's at least the first step to try to see if this can be replicated in simulation.
And so by simulation, you mean that you're actually just modeling the material itself in a sort of simulated physics environment, or that you're taking the actual material and throwing a kind of constructed beam of energy that simulates different forms of natural radiation to it, or what?
I'm not sure how I would do that. I've already irradiated it. So I'm not sure what you mean. I don't have the sample anymore. I'm talking about a computer simulation, and I don't have money or time to. Maybe somebody else does, like I think Mark Sokol. I'm not literally trying to build the same material. That's not at all what I mean. Yeah. I can't afford to get all these materials. Some of these are rare elements. Like no, that's a non-starter for me. I'm talking about creating a computer model in the same physics simulation packages that are used by nuclear physicists to model fission reactors, fusion reactors, things like that. Those commercial and as well as proprietary software packages that's used by nuclear scientists.
Okay, so when you do that sort of simulated experiment, you model the material, or at least not the material structurally, but you model the composition.
Yeah.
And you simulate different sort of radioactive conditions or radiating conditions for it. What question might that answer? Like, what could you foresee getting out of that with the various like results that it might provide?
Well, just throw neutrons at it in simulation and see, does it actually absorb or reflect neutrons? I don't need to do different types of radiation. I just want to literally replicate what I saw with the plutonium. I just want to start by replicating that. So I don't care about anything else. So I'm not sure me. I would just specifically focus on replicating. I would take like the energies of neutrons that come from plutonium, the spectrum of neutron energies that come from californium, and I would just replicate what actually I did physically in the lab to see if I can explain the lack of activation from the plutonium, especially.
And so we should say
I have a very specific goal. Yeah.
This particular kind of experiment with it is exactly the sort of thing that you're saying Oak Ridge totally omitted.
Correct. And in fact, well, no, it's worse than that. It's much worse than that. So I'm shocked that they didn't do NAA, neutron activation analysis, which is the acronym for what we've been talking about here. I'm shocked that that's not in the report. Maybe, it's in the classified portion because there's a 90-page classified report. We're only allowed to see these few pages. But the thing is and FOIA is never going to work because they put it behind some wall of some private company. It's a long story. We don't want to get down that rabbit hole. Okay. But we're never ever seeing that 90-page report. But basically, they in their public report that they did with Arrow, where is the neutron activation analysis? So here's what shocks me. They opted for a destructive analysis to get the isotopes when instead they could have done neutron activation analysis and get this, Oak Ridge National Lab, I learned a few months ago, they're the world leader. They're one of the world leaders in neutron activation analysis. So to me, that's very bizarre and very suspicious that they didn't do it. Why? Why wasn't that their first go-to before destructive sampling? That's what I don't understand. It's just, I know neutron activation is not perfect. It has its own drawbacks. Every technique has drawbacks. Nobody's got a magical Star Trek tricorder, right? So neutron activation versus mass spec, they have pluses and minuses. Because neutron activation, for example, there could be a downside if the sample is not properly cleaned. You could have something on the surface of it that completely has nothing to do with the bulk of the sample and completely blocks your signal, like overwhelms your signal, and that's known as parasitic activation. But at the same time, NAA is non-destructive, but ICP-MS is. So there's no one perfect technique. But if you're going to be serious about determining what something is made of, then you need to mix like 3 or 4 or even 5 or 6 techniques, and you need to do them in order, obviously with the most destructive ones coming last.
So I want to ask this question as delicately and strategically as I can. I know you do not know what Oak Ridge, all the things that Oak Ridge did with that piece of material, but if you were to assign probabilities, would you assign a higher probability to theory A that they simply did not do that neutron activation analysis, or that they did do the neutron activation analysis and for some reason it's not in the report that we got publicly?
I strongly suspect, since they're a world leader, I think they did it, and it's probably in the classified section. And the conspiratorial side of me might say, oh, because they found some ratios that are not from Earth and they don't want to reveal that. But there's still mundane explanations for that, not revealing techniques. But here's the thing: NAA is not a classified technique, especially if I can half-ass it at a no-name university where I am. Right? Come on, there's something really weird going on here that they wouldn't have even done it. So I strongly suspect they did it, and are just trying to pretend that it's this sexy thing that no one else can do when, I'm doing it. And that's my suspicion, is to preserve the aura that the national labs are just like better than everybody else. And they're just this magical place where they have all this great tech, when I think that they won't want to burst the bubble of that reputation of the U.S. national lab system, which I should say, I shouldn't crap on it. It's a great system. But at the same time, I'm not blaming them, because their funding has been gutted, I'm sure, even before Trump. So just to be clear, I'm not blaming any scientists. Many of them are my colleagues at national labs. But I'm wondering if some of it has to do with just budget cutbacks that just go back even the previous few administrations, that are causing loss of expertise at the labs. So I think that if there's fault to be assigned, it is not with them, and it's not with the scientists at the bottom of the totem pole who are just people like me. I think it's with administration and bureaucrats where any fault lies, in terms of incomplete results or not fully published, or, you know what I mean? Yeah.
Scientists are not the ones who generally apply classification to results in the first place. So
that's right. Exactly. So I think, and I've met some of the scientists at Oak Ridge, and I tried to probe them on this. You can't talk about UFOs. That's a killer. That destroys a conversation, mid-conversation, right? So, but I didn't get very far then as a result. But when I actually did a tour, this is by accident. This is a synchronicity that last year I did a tour of Oak Ridge National Lab, because I just happened to be there for a conference in Tennessee for my day job, mainstream field of dark matter and related physics. But I signed up for the free tour for people who are going to the conference. And this is where I learned they're world leader in neutron activation analysis, and they play with neutrons all day. They've got special neutron reflectors. They got low energy neutron beams. They can't even tell you, right, specifically exactly how it works. But it's just, I saw their facility for doing neutron activation analysis, and it's extremely professional. So there's another theory, though. You said, probabilities, different theories. Another possibility is because of the stigma against the topic, Oak Ridge wasn't allowed to do more, because, it's a crash UFO part, and everybody sneers and laughs. So again, I'm blaming zero of the wonderful scientists and researchers who work there. But my concern is that the higher ups might laugh and sneer at the topic, and that may have caused Oak Ridge to not do everything.
It's such a strange response to, we have a piece of material we want to study, and then you say, oh, okay, go for it. But, somebody said it's from a UFO. So, and then it's like, oh, no, you can't look at. Yeah. This isn't an expensive process, this analysis.
No. And in a few months, I'm going to make a lot of these people really, really angry with me. Because I'm going to publish my results in a mainstream scientific journal. I'm not going to use the word UFO or UAP, because that's a surefire way of getting, rejected. But I'm just going to say, unknown material, unknown provenance or whatever. So I'm just going to BS it like that, and that's how it'll get published. But they're going to be pissed, because they're going to be like, well, who the hell is Matthew Szydagis? And how did he do a better analysis? Actually, that's theory A for me. Theory B of what'll happen is nobody will notice. Just like how there's no New York Times article about, the paper Kevin wrote that summarizing the entire field of ufology. Where's the New York Times article? Where's the 60 Minutes piece? Where's ABC, NBC, Fox, CNN? Nobody gives a shit, because Kevin and I are not at Harvard. We're not at Yale. We're not at Stanford. And so what I think is more likely to happen, instead of being pissed at my analysis, no one will read it. Nobody will even care. The only people who will read it were people on SCU, or people who are in this field, so to speak, and they're not all scientists. They might care. They will read it. But nobody in no mainstream media is going to care. I'm not going to end up, on Fox News or Bill Maher selling with Kevin. Nobody's going to care. And that's what's more likely is going to happen to me. And it's really frustrating, because I think I'm doing a damn good, thorough job with my students on this material analysis. And it's very disheartening and soul crushing to be continued to be ignored by the mainstream media, when I'm doing progress, Kevin's doing progress. We're doing real work with physical evidence, not just photos and videos. Nobody cares. Nobody's listening. You care. You're listening. Mike's the phone, Rich Hoffman, the people who are in this area, but nobody else seems to care.
What would you have them do, though? I mean, I do care. I think it's fascinating and important, but it seems like something the mainstream media would get wrong.
They should.
They would always say, like, oh, it's a UFO. We've proved that, but that's not what you're saying.
No, I'm saying it's probably terrestrial. I have not finished the analysis yet, but basically there are two possibilities, and both of them the mainstream media should be tripping over themselves to cover this story, and they won't. Mark my words, they will not. Option one, we've proven a piece is extraterrestrial. How the hell can you not cover that, right? That's just, how stupid would that be? And the second thing is almost as spicy of a story, is lowly University of Albany runs circles around Oak Ridge National Lab and Arrow and does a better job. Like, how is that not a mainstream media story? That's a very exciting story, that a university that's been kicked to the curb, that its funding is constantly going down, being beaten, and yet they can still do a better job than the federal government. A no-name scientist like me can do a better job than federal agencies and national labs. That is a newsworthy story. Come on. That's a 60 Minutes, New York Times worthy story. Like, what the hell are wrong with reporters, right? If they don't cover them. And so it just boggles my mind, because mark my words, there won't be a single story. Mark my words. My paper will quietly go into the night at the end of this year. You'll know about it. SCU will know about it. Nobody else is going to care. Nobody. Maybe if I'm lucky, I'll get one or two tabloid articles, right? But no mainstream stories at all. That's what's going to happen. That's what already happened with the UAPX paper I wrote and with Kevin's paper. Where are the big mainstream stories? Where are they? A few websites are covering them, but where's the huge trumpeting of the fact that we broke through the stigma at a major journal in aerospace science? So I just get so disheartened that I want more people to just care. And I don't want fame. I don't want money. I just want like a bullet point even in like the New York Times on page 15, right? I'm not asking for a front page thing. I'm just asking to stop being so thoroughly ignored as if I don't exist compared to all the other players in the UAP arena, like, Gary Nolan, Avi Loeb. They get all the press. But meanwhile, I'm patiently working with no money or on a shoestring budget, desperately trying to get analyses through and published, and nobody is covering people like me or my colleague Kevin.
Why do you think that is?
Because we are not at a major university, number one. Then number two, the conspiratorial option of me says, because we're getting too close to certain truths. And so the best approach is to just ignore us. Don't give us any time of day. But that's by Occam's razor. That's too conspiratorial. A more likely reason is I'm not at Harvard, Yale, Stanford, Princeton, University of Chicago, which is my alma mater, by the way, but I'm not at a recognized university. I'm at an up and coming good university, University of Albany, but nobody's heard of it. And so as a result, I really think that what we're seeing here is a different type of stigma than UFO stigma. What we're seeing here is the you are not at an Ivy League school stigma. That's what we're really seeing.
I think another reason might be that you are not yourself like an avid self-promoter. Not to say there's anything wrong with avid self-promotion, but there are people in this space who do get a lot of attention, and it seems to me partially because they've decided to lean into that and become a kind of media personality, media celebrity about the UFO topic. And I don't see you trying to do that. You seem more interested in the work itself. Yeah,
I just want the truth to come out. I don't want to become a media personality. And again, when I say it should be covered by the media, I'm not saying they should call me up and do an hour-long interview that like they did with, Ryan Graves and Dietrich and Fravor and stuff like that, David Grush. That's not what I'm saying. I'm just looking for, like I said, the one bullet on page 15. Like, I am not saying I want to be a star or anything like that. I just want to find the truth, and I just want to make enough money to survive. I don't want to become rich, and I don't want to become famous. And I'm doing very well at not becoming famous. Contact in the Desert, for example, hasn't invited me a single time. Again, they pretend I don't exist. Kevin, same thing. And so I'm not famous in UFO even field. And I think part of it is because I just want to do real work. And to me, real work is not making YouTube videos where I promote myself. To me, real work is publishing papers like Kevin and I do.
So the question I would ask at the end is, what do you think this analysis shows? Like, I know it doesn't conclusively show, and it's not a smoking gun. Smoking guns are like extremely hard to even imagine what they would be in this space, apart from like a UFO landing in front of everybody and like staying there forever and letting people analyze it. But it's not a smoking gun. You're not saying it is, but it doesn't say nothing. Like if you had to lay out your theories of the case, of what you have, what this material is and where it came from, what seems more and less likely to you?
I can tell you exactly. I don't know how much trouble we're going to get into with Rich, though, because he doesn't want anything revealed from the SU conference at all until paid registrants, have seen my video and of all the talks on Hoover. So he might be a little peeved that I'm just spilling everything from my talk here with you. But
I'll take the brunt. Okay.
You take the brunt, please, because I'm just so tired of fighting with people. there's so much also toxicity I feel. But Rich Hoffman's my friend, and I don't want to anger him. But basically, I have a pretty solid. I have a pretty solid hypothesis already. Again, it's still preliminary because I haven't finished all the analysis. And actually, it was my colleague Cecilia. I give her credit for this. She's our Dana Scully at U Albany with me and Kevin. And it was also my student Andrew who came up with this together. They found some smoking gun damning evidence that it very much seems to be terrestrial. And also, we have a potential explanation for what it is. It looks like it's a casing, either of a nuclear missile or of a nuclear weapon that maybe didn't detonate completely. And so it had a chemical explosion, it didn't fully detonate, so it didn't vaporize all of itself. And given the location near White Sands, where it's allegedly had to have been picked up, this kind of makes sense. Now, is that a perfect explanation? No, it's not. Because if it truly is from 1947, the material layering, the so-called metamaterials or quasi-crystalline structures that, Jared has been studying and he's been doing an amazing job. When I said earlier, people throw around the term metamaterials without knowing what it is, I wasn't including Jared with that because he actually knows what he's talking about because he's actually studying the part under a microscope. But most UFO people are like, oh my God, it's metamaterials. When they have no idea what that word even means, if I ask them to define it, they wouldn't have a clue how to start defining it. I did for you earlier. But basically, my point is that the technology was beyond 1940s technology. And even if the part, let's say, was from a different crash or something else and it's from the 80s, we still didn't have the technology. So, and also, if you just Google and look up material bomb casings and reactor casings, the elements don't match, not perfectly. And so could it be some black ops classified thing? Could be NERVA. This came up in the SU conference. Could be this nuclear flight program. Micah Hanks had suggested that to me. So there are potential terrestrial explanations. So right now, the one that fits the most facts for me is that it's some sort of black ops terrestrial program of extremely advanced technology that has something to do with neutrons and nuclear radiation. And that's going to disappoint a lot of people. Because here's the thing, you were saying earlier, Michael, I don't want to become famous. I sincerely mean that. If I wanted to become famous, I would sit here and lie to you and I would say, oh yeah, it's 100% sure alien. To be clear, I'm not finished with the analysis and I might find some evidence of it being extraterrestrial still. However, I'm not going to sit here and lie to you and say it's 100% for sure an alien part because that would make the story go viral. Along into the mainstream media as well. But I'm not going to lie just to advance my career and advance myself and get fame and fortune. And same thing happened with the movie A Tear in the Sky. We found this hole in the clouds and it was said it was a wormhole. We have no proof it's a wormhole. That's way too speculative. And so I'm going to stand for truth. And that includes disappointing people when I do find a mundane explanation, either for a photo/video or a physical part like I have. But to be clear, my friends, Jared and Mark, they disagree with me. They don't think it's mundane, but for good reasons. They poked holes in my explanation, and I just explained to you the holes in the explanation. Why didn't it get vaporized in the explosion? Why does it not match the composition of any known nukes ever manufactured in any decade? It doesn't match. And so there are very good reasons to poke holes in my mundane hypothesis. But again, you asked me right now if I had to put money on it, my best guess is it's terrestrial, and it's very it's from some kind of very top secret project that is somehow connected with nuclear radiation involving either planes, reactors, bombs, or things like that.
What would count as evidence that it's definitely extraterrestrial and technological in nature? It sounds like you've landed on it being technological.
I think it's without a doubt technological. And the Arrow report concludes that it was made by an intelligence. The elements are not put randomly. It's clearly from an intelligence. Okay. one could speculate still, even that has a hole in it, because you could say, oh, it was created during a nuclear explosion, just like trinitite. So there's a hole there in the explanation, but still, it's not a big hole. It's not a big plot hole. It's pretty clear that it's almost certainly intelligently constructed. But how to show that it's extraterrestrial, that's very, very tricky. Arrow has already shown 2 of the elements have terrestrial isotopic ratios. I'm going to check them on that if I can, if my data has sufficient quality and statistics to do that. So I'm going to check on that. But also, I would need multiple elements that have the wrong ratios. But even that, it's not 100% then that's extraterrestrial, because how do we know that the isotopic ratios weren't changed because it wasn't a nuclear explosion, right? So there is an out. There's still an out there. And so especially since I've demonstrated it seems connected with the nuclear space, that unfortunately also brings in a potential counter explanation. So given that, I don't think I'll ever be able to say with very high certainty it's extraterrestrial. The best that could happen is I might say, look, a few of these isotopic ratios are off, and leave it at that. I don't think, because at least 2 of the elements do seem to have terrestrial ratios, it's going to be very hard to, with a straight face, conclude, oh, yeah, this is extraterrestrial. I think, unfortunately, that ship has probably sailed for this part. But, we can go into crypto-terrestrial, ultra-terrestrial, all that other stuff. Because, technologically, it doesn't seem to have been what we were capable of in the 40s or even in the 80s or 90s. It's cutting edge even today when you look at how it's constructed and how the elements are bonded together. It doesn't seem, and this is in the Arrow report, it doesn't really seem, I think Eric Davis said it best, it's a part out of time. It doesn't match with the time frame that it's alleged to have come from. I don't want to get into Mike Masters and, aliens are from the future. He's got a whole thing there. I did forget to mention, though, here, but again, I'm going to get in so much trouble with Rich because I'm just spilling the beans from the SCU conference. But, look, people still need to pay to go see, or if they've already paid the Hoover, they need to go see my graphs.
I was there for it. I don't think that this is actually ruining it. You said a lot in your presentation.
I did, that isn't covered here, exactly. But I did find uranium using 2 different techniques. And to be clear, I'm using not just neutron activation, also X-ray fluorescence, which I'm shocked that, why did an Arrow or an L do that too? I use X-ray fluorescence. And I would love to try, I don't have the part anymore, the Raman scattering, which can tell us what compounds are in there, what molecules. So like I said earlier on this episode, there is no one magic way to determine what something is made of. It doesn't exist. We don't have Star Trek tricorders. So the best way to determine what something's made of is to use 2 or 3 different techniques. And if Oak Ridge did that, then it's not in the public report, unfortunately. I think that's my conclusion to this whole episode. I mean,
that's a fascinating and substantial conclusion. It's not the sort of on the order of information that we want. We want somebody to say this is either from Earth or not from Earth, or it's either technological or it's not. But you give pretty high levels of confidence about both of those questions. It seems to be from Earth and it seems to be technological, though people doing the structural analysis might have some disagreements.
And that's fine.
Story.
Yeah, and that's fine because the structure is another part of the puzzle. If the structure is beyond human capabilities until a few years ago, or still isn't, that's pretty damning in itself. But it's really confusing because, we have even more evidence. My student Andrew discovered that there's argon gas trapped in the sample. And that makes perfect sense for a terrestrial sample because argon is used in magnesium and zinc mining. What are the 2 most common elements in the sample? Magnesium and zinc. So that's really damning that it's a terrestrial, or, aliens happen to also use argon when they're mining magnesium and zinc. So that's a big stretch. And so we've got some pretty damning evidence it's terrestrial, but at the same time, we've got damning evidence from Jared's work and Mark's that it doesn't belong. It doesn't belong, at least in the 40s, and potentially even if we fast forward to the 80s and say, okay, we don't have an unbroken chain of custody. Even in the 80s, it's kind of like we were not. Who manufactured it? For what purpose? It seems to be really cutting edge technology when you look at it microscopic.
So maybe the final conclusion we can draw about this is that the UAP community has a lot of really good scientists working in it. They oftentimes find themselves in possession of materials that really do have strange properties and don't have very clear explanations that fit with our understanding of the history of materials that we've been manufacturing. And so it does leave an open question. We are doing real work. You are doing real like laboratory science on things that are very strange.
Exactly.
On the final point here, we have a few links that we can stick into the discussion here, but you're doing another project that might be of interest to people. You're teaching a course on sort of ideas of advanced propulsion. Is that right?
That's correct. Yeah. And so it's being offered through SUOPS, Society for UAP Studies. And I would love for everybody in Society for UAP Studies and everyone in SCU, Scientific Coalition for UAP Studies, to take my class. And you could just ask former students how they really, really enjoyed it. And it's not just exotic propulsion, so I cover everything. So in the beginning of class, I talk about rocketry. I talk about the beginning of rockets. And over the course of the class, I go into more exotic things like electromagnetic-based or warp, space-time warp-based propulsion. As the class goes onward, it's 8 weeks, once a week for 8 weeks. And we go through we managed to hit up all kinds of topics of advanced and speculative propulsion techniques.
That sounds like a blast. When does it start?
It starts on Wednesday, August 13th, and it goes through October 1st. So it's on Wednesdays. It starts on Wednesday, August 13th, and it's at 2 p.m., 2 to 5 p.m. U.S. Eastern Time. So
you get to sit, you'll have readings that the students are going to do. Then they'll come in, there'll be like lecture and then Q&A. That's kind of the basic setup for the course.
Exactly. So there's no homework because it's not, a quote unquote real class.
You're not getting a grade.
Through my university. Yeah, you're not getting a grade, but there's reading assignments for homework. And I'm not just lecturing for 3 hours at you. We have a very, very active Q&A. And in fact, I know because I've taught this course once before. I had very active engagement from the students, lots of discussion, and I plan to facilitate that again. So I would leave lots of time. It's not just 3 hours of me droning. I take pauses where I say, are there any questions? And I specifically say, here's a question I want everyone to give me their thoughts on. So I do break it up and it's not just me lecturing the whole time. So it's also, the course is $125 per person, or SUOPS offers multiple courses. You can do the $50 monthly deal where it allows you to take different courses. There are many courses also offered by Society for UAP Studies. So there's a couple different payment plans that are possible.
So at $125 is like a 20th the cost of some university courses you're getting.
Yeah. I mean, if you want to, measure it that way. But so this is not being offered through my university. I'm not taking away from my university time. So this is on my own free time that I'm doing this. Someday I know that Mike, who's the Mike's-a-phone's director. I know that he wants to eventually, and I would definitely help him with this, turn things into official courses at people's universities. I believe that's one of his end goals. And I would definitely help him with that at my university, University of Albany, to try to get that down the road at some point.
But for the meantime, the SUOPS courses are taught by professors at very good universities. They're exactly the level of education that you would get there for a super reasonable cost. And you get the time with people who already have a vested interest in this topic, which is not something you can get most other places.
No, and Mike, to be clear, he vets everybody. You have to have a Ph.D. or an advanced degree in the field you're trying to talk about. And so you're not going to just have amateur UFO enthusiasts give a quote unquote class. That's not what's happening here. Mike vets these people. And I'm sure you do too, right? You are on the SUOPS board. You're part of the educational plan. I know that people are vetted. You just can't have random person who has no idea what they're talking about teach one of these classes.
They're all real professors. So
exactly.
Awesome opportunity. Matthew, thank you for being here. This was great. Both episodes are fantastic, and I hope that we don't get in too much trouble for talking about the content that you already put out.
Rich is not going to be happy because people have to pay for Hoover, right? He wants people to pay for it. Yeah.
Well, I think this is a good lead into Hoover because you really genuinely did not cover most of the stuff that you give in your presentation. And there are lots of other presentations that you get to see when you sign up for Hoover, which there will be.
Exactly.
The entire conference.
People can say Jay Stratton's talk, and I know that Rich was stamping out people on X from leaking what he talked about, but you could just pay to go watch it on Hoover. And look,
it's like $75 and you get 20 presentations or something.
Look, I know it's cost money, but here's the thing. SCU is a nonprofit, just like a SUOPS is a nonprofit. They need money in order to keep the lights on and to host conferences like this, because there was the in-person component. And the reason why, my course costs money. Look, I need to live. I don't make enough money as a university professor. I make a woefully inadequate money teaching my regular courses at the university. So we're not trying to become rich. And so I really hope that people can find the money to do it properly and pay for the content.
Yep. You're not just buying the content, you're helping continue.
Exactly. You're allowing people like me to keep doing this when I'm not paid to do it. So this is officially right by like the federal government. And so your money is not making me rich. It's making me stay afloat. I have 4 kids and a mortgage. And for Rich, it's helping SCU stay afloat. I don't see money from the Hoover, but that helps Rich and SCU stay afloat. So I do hope people pay and don't just try to try to steal the talks from. I don't think
they will. Our listeners enjoy the content and support this mission. So please follow the link down in the episode description here, and you can sign up for the course that Matt is teaching, or you can go and also get access to the entire SU 2025 conference and see all the presentations that it contains. Matt, thank you.
And Michael, correct me if I'm wrong. It's not too late to do it retroactively, right? Even if you miss the conference, you can still pay. Right. And look, if someone is absolutely unable to pay, all the talks, including mine, will be made available on SCU's YouTube channel in a few months. It's going to be a few months because, again, Rich Hoffman must prioritize the paid registrants.
It's like December or something.
Yeah, exactly. So if you're really poor, and I get that, tons of people in that situation, including, in the US, like tons of people can't afford that. They live paycheck to paycheck. So just be patient, please. Everything will be out by the end of the year on every talk, including Jay Stratton's, my talk, everyone's talk at SCU. It's going to be up on YouTube by the end of the year. And I know this because Rich does this every year. And like Old Faithful, right? He puts it up in December every year. He puts up the talks from the June conference. So if you really, really, truly can't afford it, please just be patient and wait for the YouTube videos.
Yep. We're not trying to hold it back from anybody, but if you can.
Exactly. We don't believe in NDAs. We're not trying to hold secrets. It's not what it's about. We believe in openness, but we also believe in, making a living wage, So just please, just patience, everyone. Yeah.
Well, let's end here. We've got a second part coming up. The Anomalous Review is a project of the Scientific Coalition for UAP Studies. It's hosted and produced by me, Michael Glosson, and edited by Kelly Michelle. Our theme song was written and performed by Telma Crisanti. Communication and PR work is by Preston Dykes. Our advisory team includes Jennifer Roach, Robert Powell, Richard Hoffman, Joshua Pearson, and Larry Hancock. To find out more about SCU, check out explorescu.org.